It could reshape the entire planet. That is the alarming cry echoing through the corridors of climate research labs worldwide, as experts scramble to understand the sudden transformation happening in the Southern Ocean. For decades, scientists took solace in the idea that Antarctic waters were growing fresher at the surface, forming a protective shield for sea ice. Now, seemingly overnight, that shield has cracked, and warmer, saltier waters have begun surging upward, eager to test the limits of the ice that once confidently covered vast reaches of our polar frontier. For nearly 4 decades, the vast expanse of Antarctic sea ice defied the stark realities of global climate change. As melting occurred elsewhere, the southern ice seemed resilient, buttressed by layers of cooler, fresher water near the surface. Those fresh waters developed slowly through a combination of glacial melt, precipitation, and a stable ocean structure, one in which saltier waters remained deeper, while the surface acted as a barrier, effectively insulating the ice from threatening warmth. This phenomenon, known in oceanography circles as increased stratification, offered hope that perhaps the Southern Ocean was not heading down the same treacherous path as other vulnerable parts of the world. But that hope has eroded. It all harks back to puzzling gaps in sea ice observed from space in the mid-1970s. Satellites then, still novel tools in the realm of observational science, recorded mesmerizing holes in the Antarctic ice called polynyas. One particular recurring hole, the Maud-Rise polynya, occasionally sprawled over an area larger than the entire state of California, leaving scientists agape at this new phenomenon. That massive region of open water in the Weddell Sea suggested that deeper, warmer ocean currents were upwelling, melting the ice from below. Yet, as time wore on, these gigantic polynyas appeared less frequently, and finally, nearly 4 decades passed without such a dramatic recurrence. Now, as if awakened from hibernation, the Maud-Rise polynya has returned, accompanied by its compatriots. The satellites that once revealed its breathtaking scale have again captured footage of these yawning openings, prompting a cascade of new research. But this time around, the story is decidedly more disturbing. For years, analysts argued that the top layer of water around Antarctica was freshening, a phenomenon that effectively kept the warmer, salt-laden waters contained at depth. Today, however, new data from oceanographic robots and satellite sensors reveal that the ocean's topmost layers are becoming significantly saltier, collapsing the once firm barrier that shielded the surface from the ocean's heat. This shift in salinity represents a seismic realignment in the delicate balance of ocean physics. The story goes beyond the mesmerizing spectacle of polynyas. It calls into question the fate of Earth's climate system as a whole. Sea ice, particularly in the Southern Ocean, serves as one of our biosphere's key reflective surfaces. Like a cosmic mirror, it bounces sunlight back into space, helping to regulate global temperatures. If that reflective cap continues to diminish, more solar energy will be absorbed by the darker ocean waters, reinforcing a feedback loop that hastens warming, melts more ice, and perpetuates a cycle as insidious as it is powerful. Scientists from the University of Southampton, led by oceanographer Alessandro Silvano, recently published findings in the Proceedings of the National Academy of Sciences. Their research underscores how drastically this entire system has flipped in a staggeringly short period. The fresh waters that once lulled us into complacency have neglected their protective duty. Measurable salinity increases at the surface are blending with previously quarantined warm currents below. This swirling cocktail of temperature and salinity spells trouble for the ice above, gnawing away at an extent that, not so long ago, seemed surprisingly stable in the face of global climate stresses. What makes this discovery particularly unnerving is that it defies many existing climate models. Prior forecasts suggested that continued melting of glacial ice, coupled with shifts in precipitation patterns, would sustain the stratification of Antarctic waters. That layering, in turn, would safeguard the region's sea ice for much longer than in the Arctic. Instead, researchers are now witnessing the exact opposite. Less stable water layers and a resurging upwelling of deeper waters that carry enough heat to significantly undermine the ice from below. It is a domino effect. Once the top water becomes saltier, the boundary between surface and deeper layers weakens, more warm water rises, and sea ice is attacked with renewed vigor. As these polynyas open up, they are not simply curiosities for the scientific journals. They are windows into a darker future. A polynya, after all, is a stage for rapid heat exchange between the ocean and the atmosphere. Without ice to insulate the surface waters, the Southern Ocean loses heat rapidly to the frigid air above, fueling storms and altering wind patterns. But ironically, the ocean beneath the polynea often warms further, intensifying its assault on any nearby susceptible ice. It is as though the planet's refrigerator door has been flung wide open, allowing a complicated interplay of heat and cold to run amok in the high latitudes. Why has this protective trend reversed so suddenly? That question looms large in contemporary discussions. One theory posits that changes in large-scale wind patterns around Antarctica are pushing saltier waters to the surface. Another hypothesis emphasizes the role of diminishing glaciers and ice shelves, which itself might alter ocean currents in surprising ways. We cannot overlook the possibility that reduced sea ice coverage can shift ocean circulation, creating feedback loops that lead to even less ice. The point is that this region, once considered an almost static backdrop of Earth's climate, now whirls with complexity, demanding urgent scientific scrutiny. In the mid-1970s, when satellites first documented the maud-rise polynea, scientists were stunned by its sheer size. The polynea came and went, fueling speculation about possible drivers: submarine volcanoes, unusual wind events, or rare oceanic forces beyond our comprehension at the time. As technology advanced, experts gleaned that the phenomenon was tied to the interplay of salinity, temperature, and oceanic convection. The renewed appearance of these polynyas signals that the underlying processes remain very much alive, and that conditions are ripe once again for these gigantic holes to pierce the ice that once blanketed the Weddell Sea. Let us remember that sea ice is not merely a decoration of the polar oceans. It forms the basis of complex ecosystems, from tiny algae that cling to the underside of the ice, providing nutrients for krill, to the enormous mammals like whales that depend on those food sources along their migratory routes. Penguins, seals, and countless other creatures have evolved to rely on stable ice patterns, forging annual journeys and life cycles that align with the freezings and thawings of the region. A sudden shift could unravel the intricate tapestry of Antarctic life, potentially triggering cascading effects up the food chain. Now, picture the chill of a windswept Antarctic plain, the horizon smeared with white as far as the eye can see. Then, as if a cosmic plug has been pulled, a yawning chasm in the ice appears, framed by an ocean that is no longer steadfast in its chill, but simmering with pockets of heat. That is the shocking image behind the headlines. And it is not just about heartbreak for polar wildlife. It is about a planetary story that affects us all. Scientists warn that if these polynyas continue to emerge, and if surface waters remain saltier, we could witness a tipping point from which the Southern Ocean does not easily return. The European Space Agency, through funding various expeditions and satellite missions, has underscored just how little we know about the dynamic processes swirling beneath those icy surfaces. Their satellites, combined with robotic submersibles, piece together a puzzle that once felt almost intractable. Yet the more data we collect, the more we realize how intricately connected everything is. A shift in salinity in the Southern Ocean can have repercussions on global ocean circulation, which, in turn, influences weather patterns far beyond the polar circles. Missing any piece of this puzzle could leave us glaringly exposed to climate surprises with global consequences. Now, if you are finding this revelation as astonishing as I did the first time I came across it, consider showing your support by leaving a like. It helps convey that pressing climate science matters to all of us, even if we live thousands of miles from Antarctic shores. And it might just camp the conversation in the spotlight, right where it belongs. That said, the real question is whether these findings will galvanize global action or remain a footnote in the ever-escalating climate saga. The destiny of the Southern Ocean, and arguably our planet, may hinge on how seriously we take these signals. Think about the next chapter of this story. The polynyas that are cropping up today could, in theory, expand to match or surpass the monstrous ones mapped by satellites in decades past. Each new opening in the sea ice unleashes a flurry of physical consequences. The warm ocean sneaks upward, banishing the frigid protective barrier that once kept the ice safe. Storms build as temperature gradients stretch the atmosphere in new ways. Meanwhile, marine life struggles with the chaos of a rapidly morphing environment. Though polynyas sometimes refreeze, each reemergence hints that the conditions behind skyrocketing salinity levels and weakened stratification might only become more entrenched. Funding from agencies like the European Space Agency aims to ensure that more advanced submersibles and autonomous sensors roam beneath the ice, capturing the hidden convulsions that signal shifts in ocean currents and temperature gradients. But data alone will not be enough. We are dealing with phenomena that must be interpreted in the context of climate modeling, political will, and global consciousness. The deeper we look, the clearer it becomes that nature is playing a complex game, one in which the rules can change with startling speed. Past assumptions about the Southern Ocean's resilience have shown themselves to be fragile. That is why efforts to refine models are critical. Accurate predictions hinge on understanding how salinity shifts might alter not just local phenomena like polynyas, but the very engine of global oceanic circulation known as the thermohaline conveyor belt. If the Southern Ocean experiences a more significant breakdown in its protective layering, it could inject warmer water into circulation patterns that distribute heat and nutrients worldwide. We might see ramifications in monsoon patterns, drought frequencies, and even hurricane intensities across the globe. No corner of the planet would remain untouched by these changes in oceanic currents and temperatures. Perhaps the most perplexing aspect is how abruptly all of this has occurred. We recall that for nearly 4 decades, the strong layering of cold, fresh water at the surface was the norm. Scientists observed that trend and built it into their projections. They told policymakers that the Southern Ocean might actually gain sea ice in certain scenarios, or at least not lose it as rapidly as the Arctic. That assumption now stands on shaky ground. The abrupt return of polynyas, combined with the sudden jump in surface salinity, hints that there may be previously overlooked triggers, potentially linked to wind shifts, interannual variability, or unknown feedback loops that can rapidly flip the system. So, what does that mean for us, living far from the white deserts of Antarctica? First, rising sea levels remain an urgent threat, as any meltdown in polar regions ultimately translates into higher seas. But more nuanced shifts in global climate cycles, like the altering of rainfall and drought patterns, can also trace their lineage to the pulses of warmer, saltier water that swirl around Antarctica. The climb in surface salinity points to an unstable ocean, one that is less predictable and more prone to extremes. Economic sectors like fisheries and shipping might face new challenges. And from a purely human perspective, the unraveling of polar ecosystems is something we cannot ignore if we value biological diversity. There is also the matter of solar radiation. Sea ice, by virtue of its bright surface, has played an outsized role in reflecting sunlight. This reflectivity helps moderate Earth's temperature baseline, but as polynyas tear open wide sections of open water, the darker ocean surface absorbs more solar energy. This accelerates warming in a positive feedback loop. Because the southern continent of Antarctica sits at the cold bottom of the planet, changes there can have ripple effects that might eventually nudge the entire Earth system toward higher temperature equilibrium points. Scientists have long worried about tipping points, and the behavior of Antarctic sea ice lurks near the top of that list. A particularly curious detail is how atmospheric and oceanic feedbacks might couple in the next few decades. If storms intensify due to increasing heat flux through these polynyas, one outcome could be more mixing of surface and deep waters, further eroding any remaining stratification. Alternatively, the ocean could respond by forming more sea ice in certain localized pockets, complicating the overarching narrative. The interplay between salt, temperature, and wind is as complex as any system on Earth, and we are only at the dawn of comprehending how quickly it can pivot from one state to another. That is the excitement and terror of scientific discovery simultaneously. Remember how researchers found the Maud-Rise polynya was once large enough to dwarf entire states? If current trends persist, we might see something of equal or even greater scale, pushing the boundaries of what satellites and research vessels have ever recorded. The consequences extend well beyond cartographic trivia, however. An enormous polynya would facilitate a massive heat exchange corridor between the ocean and atmosphere, while also profoundly disrupting marine life. We might witness unprecedented phytoplankton blooms or altered predator-prey relationships as the ocean's chemical structure, its temperature, salinity, and nutrient flow drifts further from the norm we have known for so long. At the University of Southampton, the team led by Alessandro Silvano continues to refine their models and go back to historical data sets to identify precisely when and how this shift began. The question is whether we are seeing an anomaly that might revert to the freshening pattern, or if the Earth system has indeed arrived at a new regime. Cautious voices in the scientific community note that the climate can occasionally show multi-year or multi-decade fluctuations. More alarmist perspectives worry we have already crossed a threshold, or at least are dangerously close. Once the ocean becomes saltier at the surface, the process of returning to a stable stratification might be exceedingly difficult. Of course, life at high latitudes has endured countless geologic shifts. Antarctica itself was once a lush, forested continent eons ago, but the rate of change we now see is unprecedented in the short timeline of human civilization, and the stakes are monumental. Declining sea ice extends beyond scientific curiosity. It has direct connections to global weather patterns, economic stability, biodiversity, and the heritage of future generations. As storms become more ferocious and ocean currents shift, the resulting unpredictability can strain societies that are already grappling with severe climate challenges around the world. Now, if you are as intrigued by these mind-blowing developments as I am, please consider subscribing for future deep dives into the science behind our relentlessly shifting planet. Every gesture of support helps amplify these urgent messages, bringing them closer to decision-makers and communities who can raise awareness. There is a glimmer of hope that by discussing polynyas, saltier waters, and the stark transformations in Antarctica, we might spark the collective creativity needed to address our climate predicaments. Understanding is the first step to action, after all. So, where does this narrative take us next? Picture an Antarctic expedition in windy conditions, with intrepid scientists drilling ice cores to decipher the planet's past. Each sample serves as an archive, revealing layers of ancient precipitation, volcanic ash, and subtle changes in atmospheric composition. Meanwhile, beneath their feet, the ocean roils with complexities that cannot easily be read in any single data sample. We stand on the threshold between historical understanding and modern urgency. The riddle of the receding ice and surging salinity draws out both our primal fear of the unknown and our insatiable curiosity. To what extent will the Southern Ocean disrupt our climate equilibrium in the coming decades? No single factor can fully explain the phenomenon. Instead, we face a tapestry of influences: shifting wind belts, evolving precipitation patterns, hidden oceanic eddies, the meltdown of glaciers, and even potential offshoots of climate change that were not predicted in earlier models. Scale is critical in diagnosing which processes dominate. Are localized storms accelerating salt mixing, or are we observing large-scale oceanic waves that funnel salt from the deeper layers? The truth may lie in the synergy of both. Regardless, the lesson seems unequivocal. The planet can surprise us in ways that upend standard expectations, forcing us to revise assumptions about the resilience of polar regions. That is the story of a saltier ocean, laid bare in the haunting holes of Antarctic ice. The very waters we once imagined as docile guardians have evolved into restless changemakers, intruding upon the surface with disconcerting speed. In that turbulence of salty upwellings, battered ice flows, and unstoppable climate loops, we catch a glimpse of our collective future. This is not just about a remote fringe of the planet. It is about the entire Earth system, bound by ocean currents that weave continents together in a tapestry of shared fate. The sudden shift in Antarctic waters is, therefore, both a cautionary tale and a clarion call, demonstrating that the climate narrative we thought we understood can pivot dramatically, demanding our constant vigilance and an even deeper dive into the mysteries that shape our shared home.